Good morning, friends. A hearty welcome to my YouTube channel. Myself, Professor M.H. Annaya. In today's video, we are going to work out a problem on the development of a rectangular pyramid which is being cut by two section planes, both being normal to VP or perpendicular to VP. And these two meet or intersect at the midpoint of the axis. So first of all, let's see what is the question for today's video. It reads like this: a rectangular pyramid of base 20 mm, 40 mm, 20 by 40, with height is equal to 60 millimeter, resting on its base on HP with a longer edge of base parallel to VP. We'll stop at it so that we'll be able to write down the initial or the top and front views of the given pyramid to the given dimension. Friends, it is a rectangular pyramid and it has been given that it has got a rectangular base. This is 40 by 20. It is resting on HP on its base such that one of the longer edges, not this longer edge 40 mm side, is parallel to VP. We will place it on HP like this and obtain the corresponding top view. The top is going to be a rectangle with the diagonals joined like this, and front view is going to be an isosceles triangle with base equal to 40 mm and height is equal to 60 millimeter. So let us complete that part of the question first. So we will mark these corners as A, B, C, D, A, B, C and D. Here you can observe that AB and DC are the shorter edges, AD and BC are the longer edges. So these two longer edges of the pyramid are parallel to VP. And this is the front view of what, friends? Let us transfer all these points of the corners and the vertex O to the front view. So you are going to get A dash, B dash here. This is C dash, D dash. O dash is the vertex, O1 dash is the center of the base, and this is the axis of the solid. So we have completed the question up to positioning of the solid and is cut by two section planes. Now let's move on to the part where it is being cut by two section planes. So there are two section planes, both are being normal to VP. One of them is horizontal like this, the other is inclined at an angle of how much? It is given as 40 degrees to HP. Both of them meet at the midpoint of the axis. So let us locate the midpoint that is at a height of 60 by 2 from here, and I will show you here. So this is the midpoint of the axis, which is at a height of 30 millimeter from the base of the solid, that is base is ABCD. And let's mark on this the section planes. So one of them is horizontal. So I am going to write a section plane here, a horizontal section plane, and I will mark it as 1 and 1. 1, 1 is the horizontal section plane. The second section plane is at an angle of 40 degrees to the horizontal. So I am going to mark the section plane, say this is S2, S2, or simply say 2, 2, which is at an angle of 40 degrees to the horizontal. So we have marked both the section planes, and since they are normal to VP or perpendicular to VP, you see them as straight lines in the front view, that is 1, 1 and 2, 2. Friends, now let us mark the portion that is retained for development. So this part below the section planes is retained for the purpose of drawing the development of the solid. Now friends, after marking this will give you, this figure shown will give you front view of the solid, this is the top view of the solid, and next we have to draw the development of the lateral surface of the lower part of the pyramid. So this is the section planes 1, 1, 2, 2, and this is the portion say P. I will just mark P here, for which we need to draw the development. So friends, you know very well that all developments are drawn to the true shape or the true size or the actual size of the object or the solid here. Now friends, if you observe the front view, you see O dash, A dash, O dash, B dash, O dash, C dash and O dash, D dash. The four slant edges of the pyramid. If you observe, none of them is parallel to VP. And since we have to draw the development to the true size, we have to get the true size of this slant edge. So friends, what I do, I write a horizontal line from here. Taking O as center, OC as radius, I draw an arc. And this arc will meet the line drawn through O here. Draw a vertical line from there. It will cut XY here. Join that. This particular line I am drawing, the dotted line, will give you the true length of the slant edge. This is the most important part of the question. And friends, now after getting this true length of the slant edge, let us commence the drawing of the development of the lower surface of the lateral portion. So friends, here I am going to draw a vertical line of length is equal to TL. Say this is the true length we have got. And after drawing the true length, friends, I am going to draw, taking O as center, this true length as radius, I am going to draw an arc. So this arc is drawn taking O as center, true length as radius, I have drawn an arc. Now after obtaining the arc, friends, let us mark the base edges AB, BC, CD and DA. You know, here the complete base of the solid is intact and you have the provision to commence the development from any one of these slant edges. Say I am going to commence from point A. After A, you should get point B at a distance of 20. Say this is 20 mm, mark B. After B, you should get C, which is at a distance of 40. Say this is 40. Then that CD is 20, again 40. So like this, friends, we are going to have all these four slant edges marked on this sector. This shorter being 20, the longer is 40. So friends, we have got like this. After getting this, friends, you know very well, if you just observe the figure, the complete base, that is AB, BC, CD and DA are intact. That is to say, none of the section planes are touching the horizontal base. So friends, I can show all these base edges by straight line. So I will write down A to B, this is B to C, C to D, and this is D to A. I have shown all this by visible lines because we do not have the section planes cutting them. So none of the section planes touch the base. This is the base of the solid. And now friends, let us commence with the marking of the points where section plane 1, 1 is cutting the solid. Friends, 1, 1 section plane is cutting the slant edges O dash, A dash and O dash, B dash at this point. But O dash, A dash and O dash, B dash are not the true length. Hence, I am going to shift this or transfer the true length line. That is the last line. And I take this measurement on OA and OB in the development. So on OA, on OB at the same height, again on OA. So we have got 3 points here, friends. And next, friends, the slant edges OC and OD are cut here. Slant edges O dash, C dash and O dash, D dash are cut here. But again you observe that they are not the true length. Hence, shift that point to the last true length line which you have constructed. Take that measurement on OC and OD. Say somewhere here you get OC and OD. So 2 points here and 2 points here because it has got 4 points there. Let's number them as 1. This is 2, 3, 0.4 and this is again point 1 because this is OA. So on OA should have the same point 1 and 1. Now friends, the total base is intact, and whatever the points you have got here, these 4 points are to be joined by straight lines. So in other words, any pyramid or prism or a cube is cut by a section plane. The points obtained by the plane are to be joined by straight line. So I am going to join 1 to 2. And friends, before that, there's a very important point here. Even though the problem looks so simple, the important part of this I will tell you, friends. So you got 2 points here, 2 points here. But these two are meeting here. So there is a common point, which I will call it as K. There is a common point for section plane 1, 1 and section plane 2, 2. But how to locate it? If you observe the front view, friends, this K is exactly in between this AD and BC. So I will take this AD midpoint and then BC, the midpoint of that. AD and BC. I will take the midpoint and simply join that by a very thin construction line like this, because we have got a common point where they are intersecting. So friends, this common point K, common for both 1, 1 and 2, 2, is to be obtained by shifting that to the last line here. And that distance has to be marked at the so-called the midpoints of that. This is one point like that. This is the other point. Friends, we have got all these points. Let us number them now. This is 1, 2, and this will become point 3. Point 4 is here. Point 5. Finally, point 1 here. Join all these by straight lines. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to this point, finally here. And friends, now all this construction, additional construction like this can be removed or to be shown by thin line. Only for the purpose of explanation, I have given like that. So this edge has to be there. Now friends, after getting this, let us see what is the portion that is left over in the development. Portion on O dash A dash and O dash B dash. That is 1 to A, 2 to B to be retained. So I am going to mark this 1 to A visible line, 2 to B a visible line, and this. So friends, you can observe here, this line, the section plane 1, 1 is parallel to this longer edge or to the base of this. So this line should be parallel to this. I will say like this. This line should be parallel to this. And next friends, here this common point is K, I told you. So here this line is to be parallel to this line. Okay, this is parallel. And this will be at a different height. Again, this to be parallel to this. These two lines are parallel to each other. So friends, we have got here 1 on OA, 2 on OB. Please be observing 1 on OA, 2 on OB. And this point 3 is a common point. 3 and 5 is marked as K. They are the common points, 3 and K. And friends, here, okay, this is how we've obtained the development. And this portion of the solid below the section plane are to be marked by dark line. So all these base edges which have got dimension 20, this is 40, this is 20, and this is 40. All this dimension you have to make, and you can call this as development of P, the portion of the solid below the section plane. Friends, I hope the presentation was interesting, and you please go through the complete video. If you like this video, do share this with all your friends. Thank you for watching my YouTube video. Have a wonderful day.